Hey everyone, welcome back to the channel where I'm going to show you some opportunistic wireless encryption frames or OWE frames to show you how an open SSID can be encrypted with the unicast and broadcast data traffic between a device and also an AP. Now I'm going to show you how I was able to capture those frames first before going into those details. So I used an AirCheck G3 to capture those frames in the 6 gigahertz spectrum, and I'm using an Ingenious CW336 access point, which I have an SSID configured in the 6 gigahertz spectrum as well. So if I go here to share my screen, you can see this. This is in the Ingenious portal for this AP. This is the SSID that I've set up. It's enabled and I have it only broadcasting under 6 gigahertz. And that's because in 6 gigahertz, you have to use OWE instead of just an open SSID where it is unencrypted. And that's where you see that in 2.4 and 5 gigahertz. So if we go then to my AirCheck G3, which I have a remote session right here, you can see I'm showing the channel map. The AirCheck sees one AP on channel 5, which is a PSC or preferred scanning channel. If I list out the SSIDs, I can see that SSID that I have configured. If I tap into there, it is operating on one channel. I go into that channel. From here, I can then use this gear icon to perform a capture on that SSID. Right, so I click start, and then this will actually upload it to Link Live, which is what I've done in order to see the capture. All right, now we're in Wireshark. I have the frame capture here. On the left side of the split screen, there are the frames that I've captured, and on the right side are the details of the frame that I've selected. The SSID here is at on this column SSID. You can see Dystopia. It is a beacon frame. Now the beacon frame is what advertises all the details of the SSID. So on the right side, we can see all those details that some of them are pulled into these columns, such as the SSID name. To really know if you've got an OWE SSID, you can identify that in the RSN information element. If you expand that, the auth key management list will show opportunistic wireless encryption. And under the RSN capabilities, you'll see that management frame protection is required. That is required for opportunistic wireless encryption. Now in the capture, you'll see that I was able to have my phone, which was the Samsung S22 Plus, which was able to do a probe request for that SSID, and then the AP responded with a probe response. Now the magic of the OWE frame exchange and how data, unicast and broadcast data can be encrypted is done in the association requests. If we move further down, you'll see the authentication request and authentication response. Now that is part of the normal open system authentication. And normally in 2.4 and 5 gigahertz, after the devices go through these two frame exchanges on an open SSID, it'll place those place a device onto the Wi-Fi network. But here we'll look at the association request. Now this is where, again, all that magic happens. So on the right-hand side, we have the details of this association request coming from my Samsung phone. If we scroll down, there is going to be an opportunistic or a Diffie-Hellman parameter right here, and I'll hide this. Here's the OWE Diffie-Hellman parameter. Inside of the Diffie-Hellman parameter, you can see it's OWE, there is a public key from my device. Now that is key for the frame exchange, because this is how they're going to set up some keys to validate and also validate the Diffie-Hellman. If we then look at the association response frame from the access point, it also includes the OWE Diffie-Hellman parameter and the AP's public key. As a result of this, they will generate a pairwise key here for an exchange. It's going to be the pairwise key for the four-way handshake, as we will find down below. And more specifically, it's called the Pairwise Master Key. So if we go down below from this association response down to this QoS data here and expand this, we will see this is message number 1. So this is the first part of that four-way handshake. You can see all the details as part of that four-way handshake here. We go to the next message, which is message number 2. This is coming from, let's see here. So we're on this. This is coming from my phone with message number 2, and then the AP on message number 3. And to complete the four-way handshake, there's message number 4. So that four-way handshake is where the Pairwise Master Key is used to protect the frames of the four-way handshake. And as a result of the four-way handshake, it then creates the Pairwise Transient Key, the PTK key, and that's what's going to be used as the encryption keys to protect those unicast and broadcast data. So in that packet capture, that is what's happening. And after that four-way handshake, now the device and the AP can protect those frames. And so that is the OWE, the Opportunistic Wireless Encryption Frame Exchange, as how I was able to capture it with an AirCheck G3 configured, the SSID configured on the Ingenious CW336 using a Samsung S22 Plus phone. So that's how I'm able to dive into that a little bit more, see those frame exchanges, and understand how even the Ingenious implements OWE as part of their system. I want to thank you guys for watching this video. Hit a like if you enjoyed it and found it useful, and I appreciate you guys watching. Thank you.